Here's another example. A laboratory has an 800 milligram sample of cesium-137, which decays at a continuous rate. All right, so we got two things here. It's decaying, that's new, and it's still continuous. So we have a continuous decay of 2.297% annually. Find the model that gives the amount of cesium as a function of the elapsed time in years. So the fact that it's a continuous rate of decay means that RC is going to be negative. So this is going to be a negative 0.02297. Other than that, same basic principle. Amount at time t is equal to 800 times e to the negative 0.02297 t. And that will be our model. All right, now I'm sure we're going to use this for some stuff. So how much of the sample remains after 5 years? Well, we need to input the model. And I kind of have too many parentheses here. I don't need this one. I'm going to delete that. All right, so there's our model, 2297, right? Isn't that what that was? Let me check again. Yeah, 2297. And we want to evaluate the model at 5. Having trouble here. Here we go. And we have 713.20 if we're rounding to the third decimal place. Or I suppose if we're rounding to the nearest milligram, that would just be 713. What's the half-life? Okay, so I hope you remember how we approach these questions. We want to find the half-life. We just need to know how long it takes for the initial value to get to half of what it started at. And if we started at 800, then our y2 will just be 400. So we want to know how long it takes to get to 400. So that's going to be a calc intersect question. Let's go to the table and see what we've got here. So my table says between 30 and 40. So let's go to, well, actually this probably would work just fine. Let's go to 40 and we'll zoom fit. To calc intersect. And our intersection is 30.18 years. Okay. Let's find the annual percent decay rate. So this is basically finding, it's a little complicated because, you know, we've got RC. We're going to find R, but technically remember R is the growth rate, and so then we're going to change the sign once we get R. That's the way I'm going to approach this. So to get R, we just need to compute e to the RC minus 1. So that's e to the e to the negative 0.02297. Let's go to the calculator and do it. Second e negative 0.02297, no variable, minus 1 times 100, and change the sign because we're going to phrase this in terms of a decay rate. So our answer is 2.27%. Actually, that would be 2.271%. All right. So I think with this material I've moved into section 5.4b. We were in 5.4a. I think we're pretty much in 5.4b now. So I'm going to pause this video and start the next one with the 5.4b official stuff.